Hello, and we're going to get into the workbook for our first class of the data types in our Python data basics class. Okay, so just introduce Colab a little bit. And if you did not know, you all have access to Colab already. You go to your Google Drive and you go here and you see Google Collaboratory. So this is a file type. You see these two circles. It's a file type you have access to. I have the Pro subscription, but you just have the basic one. It works really well, and it just has a really great user interface. It's very similar to the same. It's the same file type as a Jupyter notebook, so IPY notebook. Uh, but it has this table of contents, this content map on the side, which allows you to navigate. So to create a heading, what we do is we create a text cell. You have coding in text cell, so we create a text cell just like that. And what we do is we go 1, 2, 3 comment signs to create different levels of headings. But you don't even see heading 1 over here. So it's only the first one that we comment that we make a heading that will appear in our table of contents. So if we wanted to make other headings, we could make subheadings, 2 stars in the next, in a new text cell, and then a new text cell as sub. Okay, this allows us to navigate our workbook, which doesn't maybe seem super like a big deal, but it eventually will become, when you have really long data science workflows, it will become very valuable to be able to navigate your workbook. So just there's some shortcut keys, and the biggest one that we want to pay, or that we likely want to use, or that we will use the most often, is Shift Enter. So Shift Enter runs the cell and just moves you down to the next one. So you get Shift Enter, Shift Enter, Shift Enter, run a few cells. Another good one is the Control Slash. This is the button for me. It's the right above the enter sign and below the backspace. So Control and then the forward slash, and then you get a comment outline. So and it allows you to select multiple lines. Okay, so let's start running this workbook. It's going to start connecting to the Google Cloud processing power and stuff just to initialize my workbook. So here we have an integer, we have a float, right? So integer is a whole number, float is 0.1. What I'm doing here is I'm printing it out and I'm putting it with inside an f string. So f string, I'm printing using the print function to print this out. And so we can see right here, what if I take away the f, you'll see what happens is I just get curly brackets and the letter A. So if I wanted to know the name of variables, this would be very handy. If I want to print out what's inside of the variable, it can't be a string. So I can use an f string to insert a variable into a string and print out what's really inside of that string. So see you get a 6 here. 2 we get there. So we can change floats and ints around. So we could change an int to a float. We change a float to an int. It doesn't notice that it's not rounding though. It's actually just getting rid of the decimal. So where are floats and integers really different? They're not different in too many places, truthfully, but there are some places. However, this is a very subtle difference, integers and floats, but it does make a difference in some situations. Data types, especially as we get to the more advanced data types, all of them really make a difference. We really have to understand what the data type is because that will enable us to do different things with whatever object we're working with. Okay? So here we have a couple strings and an integer, float, and well, let's see what this is. So J 4.0. Okay, so that's the same as an integer, but it's going to be registered as a float. So we'll see what happens. So it should work the same way, but we'll see if those same flow type, those different data types make a difference. So just to show if we add the strings, we can add E and F together. We can't multiply two strings together because that is not possible on a string. It's not possible. Uh, and here, what we want to do is if we can multiply a string times an integer, so E times G is going to give us an 4 times over. Okay, so we can't multiply by a float though, 4.1, right? Because how would you get 4, 0.1 of an, maybe a little bit of the A, I guess. And so it doesn't work. Okay, so let's try E times J 4.0, right? So if we run this one, it should work, just like 4 worked here, but because it's a float, Python doesn't even attempt it. It's just like, nope, I can't do this with a float, so I'm not going to bother. So this is really just a very simple way where integers and floats are different, but there's many other ways that are different. They're usually pretty subtle, but this is a good situation where they are different, and we'll use things like this as we go through our classes. Okay? So looking at Boolean values. So Boolean, just like a math operation, is an output of the math operation. operation. So 2 plus 2 equals 4. 4 is the output. 1 plus 2, so 3 on this side, is equal to 3. This is a logic operator right here, so equal to, and we'll go over a whole class on logic operations. Just introducing it today. I'm assigning the output to true, and we have a true value. If it is not true, 3 is greater than 2 plus 1, so 3 is greater than 3, which is not greater, it's equal to, so that does not work. We can do greater than equal to, and we get a logic operator. We want to do two logic operators. We have to enclose them in parentheses. I recommend using the ampersand instead of the and symbol, but in Python, it does not matter. In Pandas, which we use a lot, it does matter in one situation, so I recommend just sticking with the ampersand symbol, but it should normally work most of the time the same. So, but what we're going to do when we do two logic statements, this and this are both true, okay? And we'll get into more details about the and logic statement and the or logic statement that we'll discuss, but we can write them the ampersand or the word and. Getting into collections of variables. Okay, so here we have a list of kind of assorted different things. We have strings, integers, floats, a list, and another list of our really long strings. So a list can really hold anything. So if we index into the first position, 0, we're going to get data. We index into the second position with 1, we're going to get 2, and then we can see here 2, we get 3, and if we go from -1 right from the back of the list, we go -1 right here. If we go to the fourth position, number 3, we're going to get out the list. But if we wanted to now index into this list again, we can do another setup, because really what we have is a list now. So we can just index into this list just like we're indexing into the original list. So square bracket 0, and we'll get out the first item, number 1, from the second list. Okay, to slice, we're doing, remember it's inclusive and exclusive in Python. So what we're going to do is we're going to go from 1 to 4, and then 1 until the end of the list. So that's the second position until 4, so up until the end, but not the last item. And then this one's saying going all the way up until the end. This one, it says go start from the beginning and go all the way up to the last item, but do not include the last item. And then what I'm going to do is select out the last item here, and then I just it will come up a little bit, but it's a little bit more advanced to understand, but it is a good concept to keep in your mind, is that a string is actually really just a list of characters. So we can index into this list of this list of characters, this string, just like we would with a list. Okay, so we have 10, starting at 10, going up to 5, 15, but not including 15. So we get out the word holds right here. Okay. So we can add to a new list. We index into that position, we put a new value, and if we print it here, we can see new data. Okay, so we can index that position. And then if we wanted to, we could index into the string into that position and just get out data. Okay? So just like we did up above. So to cover tuples, we use them a little bit. I would say that we use lists a lot more. Tuples are really handy. The biggest thing that we need to know is that they're faster than lists, but they're immutable. So once we set them up, they can't be changed. Okay, so that's one thing, but they are faster. Okay, so here we have data, same list that we have the collection of different types of data types. Okay, so we'll index it into same way, simple tuple, first up until the fourth, but not including the fourth, starting at the first all the way to the end, and then starting at the beginning, and then all the way up to the fourth item. So we get just the exact same outputs that we did up above right here. Okay. So nothing really works different with a tuple. I wanted to introduce that, but here is one thing that's different. Slicing that works the same, but if we wanted to change data in a tuple, we can't do that. So tuples are used, I would say, a lot more in computer science, as I have not really found a reason to use a tuple versus a list that I need to use one. So we'll talk a lot more about lists because they're a lot more flexible, and we'll usually need to make a list that we're sticking things into. We're filling up with new data and stuff. So we don't use tuples that much. They are used in some situations. It's good to know what they are so that we can see them. When we see them, we know what's happening, but we just need to remember that they're immutable in that we cannot make changes to a tuple. Okay, so here we're going to do a set. A set is a collection of variables, but one of the things is that it cannot hold another list. So get an error here, it cannot hold a list. So take out the list. We can see here, what we get is the collection of variables. Basically what this is it can only hold one unique value of each type. So if I had 2 twice, it would not appear twice. You would only see it one time. So this is an unordered list. It's just like kind of a bag with things in it. There's no ordering to it. So if there's no ordering, I can't index into it. But what you can do is check if something is in this set, then check and see if there's something in there. So we can say, is water in there? No, water is not. Okay, so we can add things to our set. It works a little bit different than up above. And if I wanted to remove things, you just go dot remove or dot add, and then the thing you want to add or remove. You can see we were taking those out and then putting them in, and there you go. Okay, so let's get on to dictionaries. So I went a little bit fast through tuples and sets because we don't use them practically a lot. They're important to be aware. Look through this workbook and spend some time. Don't spend most of your time on them though. Spend most of your time on lists and then dictionaries. These are the two most important ones that you'll use quite often. Okay, so dictionaries are really handy because they tie one value to another value or one value to a list. Okay, so here what we're going to say is item 1 is the key and then data is the value. Item 2 is the key is the value. Item 3 and then 3.7 is the value. Okay, here item 4 is the key and a list is the value. So we can hold different things in a list. Okay, so just kind of highlighting that. We have a key value pair. So to access things, we can't index into it, but we can call the key, we can use the key to access the item. So if I want to access data, I can use the item to access that. Okay? If I wanted to access the item 5, we can do that here as well. Okay? So that's a dictionary is really handy, and where we'll often use it is in this simple example right here, where we have a dictionary, a key, and then we have a value as a list, which will be kind of like the column. This will be column title, and this will be the data in our column. Is often how we'll work with dictionaries. Okay? Not the only way, but one of the different ways. So here what I'm doing is we're going to import pandas as PD. So this is kind of like opening the Excel. This allows us to work with pandas functions, operations, data frames, all the functionality of pandas just in PD. You don't have to call it PD. It's a really good idea that you do though, because everyone does. We're very diligent about sticking to spelling things correctly in coding, more so than in English. So you'll see that everyone you calls it PD. So it's just good to stick with what everyone does, because as you look for code on the internet, if it is the same as you wrote, that will make it much, much easier to not copy. You always reference other people's code, and that will never end, but you'll want to make sure that you write it out so that eventually your fingers will remember, because your kind of human brain is not the best at remembering coding. Let your fingers remember the code. So always type it out, but you're always going to look. And if when you go look, it'll be really nice if their code uses the same things as your code, so it's easier to follow. It will just really make your life a lot easier if you stick to these common aliases. So for pandas, it's PD. Okay. So one of the data types that we talked about is a series. So this is a one dimension of data. So if we're going to put our data here, we can see we get a simple series. We can index into it because it has, so this is our simple series right here. Notice what happens here. So I'm going pd.series and I'm putting my simple list. So now I have my series. It's an object data type because there was not one set data type. There's lots of different things in here. So it just defaulted to object, which is basically any combination of characters and numbers. Okay, but it's a string. So we cannot do math on this column because it's a string. Okay, so even if it was numbers that are an object, you can't do that. Okay, so even this one would not be able to do math on this. So this is not the right data type. Okay. So, but we're not saving this. This is just showing us the output. This is a functionality of Colab. It's just showing us the output. If we wanted to save this series so that we could work with it, we're going to go pd.series, put our simple list in it, and we're going to assign the output of this function to another variable. Okay, so then in our other variable, we'll be able to access, number 1, position number 1. And this is the big thing about pandas, is that it has this index value. And then we'll find a data frame, it has a column title. Series don't have column titles, but they have the index values. Okay, so indexing into the list, just like would, and slicing works the same as it would with a list, like we saw before. So it's inclusive up to, but non-including the last number. So it's inclusive, exclusive. Notice that a lot, but it does really matter. Okay, so here's what I was talking about. A common way to use dictionaries is what we're going to do is we're going to go column, and then we're going to go list of values, column list of values, column list of values. And so I made sure that all of these have the same value because this would not work if it's not. They look different because they're different data types, but they all have the same number of items, so I can put them into a dictionary. It's very important is that they all have the same size. Okay? So what I'm going to do is I'm going to go take this dictionary. I'm going to go pd dot capital D data capital F frame data frame. So pandas data frame dictionary. So this a dictionary now is a data frame. So now I have 3 columns, 3 series that are all of different data types in my pandas data frame. Okay, so let's run this. And again, this is showing us the output. This is Colab showing us the output, but I didn't save that data frame to anything. So let's save it, make df simple for my data frame. And if I want to select a column, I just go square brackets column, and I select column 1, column 2, and notice that there's an integer data type, a float data type, and if we look at column 3, it's an object data type. Okay, so we can have many different data types in our pandas data frame. It doesn't really seem like a big deal, but that really allows an incredible amount of flexibility. Not to have that, it would be a big pain in the butt to do so many things. Okay, if we wanted to select 2 columns, notice here that I'm giving it a list of this column. So there's 2 sets of square brackets, but it's not really 2 sets of the equal type of square brackets. 1 square brackets are making a list, and the first set of square brackets is allowing us to select out a value. Right? So this is selecting out values from a data frame. And so we're putting a list into those square brackets. That's why we see 2 of them. If we wanted to change the ordering of our columns, we can do that. We can just select them out in a different order. So select 2 and 1. Okay. We want to select columns. This works a little bit differently. The indexing, the numbers we'll use is the same, but we're going to go dot ilock. To index, we're going to go dot ilock. And here, notice I'm getting this. The column titles is the index value, and now this is the row. So I took out 1 row. 1 dimension will turn into a series. So that's why it looks a little bit different now. Okay, so I'm going to do that ilock right there. I could slice as well, and because I'm taking out more than 1 row, we have 2 dimensions, so it's going to maintain a data frame, smaller data frame. So again, doing that, and then 2 until the end. So that works the same. If I wanted to take out 1 column, I'm going to index. I'm going to take all of the data. I'm going to take all of the rows. So just a colon is signifying from the beginning to the end, comma, column. So I'm going to say from the second one to the end. There we go. So if we wanted to change the index values, I can assign this attribute here. So dfsimple.index just gives me an attribute of the values right here. If I have the same size list, I can assign now those values to my index value, and now I can index based on, I can use ilock as the name to index into this. So ilock is iLocation, index location, and here's location is the name of what our index location is. So we can do lock for column titles and column names. So again, doing the values right here, 2, 4, 3 in the order that I chose, and then 3, 1, I'm just kind of mixing it up, and really, really flexible. I'm going to also change the column names here, and I'm going to do int float string to signify the data type of each one of our data frames. And I'm just going to assign this to the column attribute. This is not a function because you don't see any parentheses. This is a columns and index. They're just asking for details, right? If you were to run this, it would just give you the column titles. So when I copy over list, assign a list to the same size to the column titles, it will just rechange those column types. But this is an attribute. That's why there's just no parentheses. You're just asking for some details about your data frame. Okay, so to go over some basic functions, and we're going to go over a lot more of this in future classes. So here we have dot mean. We're taking a column. We're going to dot mean, and we're putting parentheses. The parentheses are really important. You won't get an error. Watch what happens if you don't use those. You won't get an error because you're referencing the function. You're like, hey, Python, here's the function. And you need to do this in sometimes, but for today, and we'll talk about that in later classes. But to know, you need to use a function. To say, hey, Python, here's a function, and use it, you need to put the parentheses around it. So here we're going to do mean, sum, and there's many functions available. So just to show you a couple of them, some very basic plotting ideas with pandas. We're going to do, if we wanted to plot the integer, we're going to select out the column, dot plot, kind equals line. So pandas plot is super quick and easy. It's really nice a lot of the time. It's not the most beautiful by default. We can make it a lot nicer, but we'll get to other libraries that are handy. They're a little bit more work to use, but they're really beautiful. So pandas are used because it's so quick and easy. But we'll focus on other libraries for more of the statistical analysis of our data. Okay, so here I'm just doing another one. I'm going to do a kind equals hist. Histograms are bucketing, putting the count of the data into different buckets. I'm going to change the color to green. I'm going to make it 4 buckets. I'm going to change my column title to hist plot. Okay, and we'll go over what a histogram is in the next classes. Okay, just to show, if I wanted to change the title though, you saw this title is very small by default. I don't like how small it is strictly by default. You're going to go PL. So what we're going to do, Pandas is built on top of Matplotlib. So what that means is if I want to do some editing, I can use Matplotlib, and it will just work on top of Pandas plot, because Pandas is essentially just a Matplotlib. It just uses Matplotlib to make all the details, make it a lot easier for us, so we don't have to do so much work. Okay. But if we want to do some editing, we can use Matplotlib. So we import matplotlib.pyplot as PLT, and we'll go plt.title. Here's my title. I'm going to change the font size to 22. So this is a quick way up here to add a title just in Pandas. If I'm maybe not showing this to anyone, that really small title is fine. But if I want to do a presentation, I usually have to do a little bit higher level formatting with Matplotlib, and we'll learn all about this. Just really wanted to introduce this concept of using these libraries together. We use Pandas and Matplotlib together because these libraries are meant to work together. Right? So this is something we have to get comfortable with, where we have different libraries, different applications, but unlike on your computer, you're stuck with just using Excel for the Excel operations. You can't really make it work with Google Sheets. They don't talk to each other. You can move it into Google Sheets, but you can't really make them talk and work with them both live. Here we can take things out of one library, out of another library, and make them work together. So this is very much just an introduction, but we'll get more comfortable with that as we go through our next classes. So thank you very much for joining me for our first Data Basics Bootcamp, and I will see you for the class number 2. So have a good one.